All right, so today we're going to be talking about Chapter 6, Lesson 4. This is all about dilations. So when we start thinking about dilations means to change the size of something, either to be getting bigger or to be getting smaller. So when we start thinking about what words we want to use, there is always going to be some kind of scale factor involved. And we're going to label that with the variable k. The reason why we want to use k is because last year in 7th grade, k was what we used to identify what a scale factor was. Now, we're going to multiply the x and y coordinates by the scale factor to get the image. Now, there's some special things we want to talk about when it comes to our scale factors. So if we say that k is greater than 1, what this means is we're going to have an enlargement. We're going to be getting something that's bigger. If we have k of less than 1, we have something called a reduction. The only thing we have to be really, really careful with, though, is we also can't go below 0. Because if we get to either 0 or below that number, we're actually going to be getting kind of a rotation. And if we get to 0, the entire figure is just gone. So as far as symbols go, when it looks like this here, we're going to start off with our pre-image ordered pair, and it's going to turn into an ordered pair that looks like this. This is our new image. Again, this k is referencing the scale factor that we're going to be learning about. All right, so example 1, it says a triangle has vertices of D, 1, 2, E of 0, 4, and F of -1, 1. Find the coordinates after a dilation with scale factor 3. So let's go ahead and do that. So D was originally 1, 2. E was 0, 4. And F was -1, 1. Now our scale factor is 3, which means that I'm going to multiply each part of this ordered pair by 3. So the x was originally 1, multiplied it by 3. The y was originally 2, and I multiplied that by 3. So our new ordered pair, which happens to be D prime, 3 times 1 is 3, and 3 times 2 is 6. Same thing moving down for both E and F. We would have 3 times 0 and 3 times 4 for E. We also have 3 times -1 and 3 times 1 for F. So E prime, 0 times 3 is 3, 3 times 4 is 12. And F prime, 3 times -1 is -3, and 3 times 1 is 3. So as soon as we are able to do this, now we can start actually looking at example 2 and actually start to graph those. So example 2, it says a figure has vertices as shown. And we want to graph the figure and the image. So we want to graph the 4 ordered pairs. So H would be back here. So back 8, up 4. J is to the right 6, and up 4. K is to the right 6 and down 4. And L is back 8, down 4. So this is my figure, and it turns out that this is a rectangle. So I connect the ordered pairs with a line, and that's my rectangle. Now, in order to find the dilated image, we have to multiply each of those ordered pairs by 3/4. So h, which was -8, 4, if we multiply both -8 and 4 by 3/4, h prime becomes -6, 3. So h prime would be here. And that is h prime. J, which was originally 6, 4, we're going to do the same exact thing, 6 times 3/4 and 4 times 3/4. So j prime becomes 6 times 3/4 is 4.5. And 4 times 3/4 is still 3. So graphing this ordered pair then, to the right 4.5, which means I go 1, 2, 3, 4, and halfway between 4 and 5, and up 3. So here is j prime. K, same thing. We have 6, -4 now. So I have 6 times 3/4 and -4 times 3/4. And that'll turn into k prime, which again will be 4.5, and now -3. Graphing this ordered pair would be down here, so back over 4.5 and down 3. So this happens to be k prime. And then our last ordered pair, which happened to be L, was -8, -4. So -8 times 3/4 and -4 times 3/4. -8 times 3/4 is -6, and -4 times 3/4 is -3. So L prime is here. So what I'm going to do is I'm going to connect these ordered pairs with a line. Like so, all the way across. And that is my dilated image. So the blue rectangle is the one that has been dilated by a scale factor of 3/4. And the black one is the original, or the pre-image figure. Alright, so last thing that we're going to do, we're going to work on finding the scale factor. So when we find the scale factor, what we really want, we want to know how to get from the pre-image to the image. And when we were doing scale factors back in 7th grade, the way that we did the scale factor was we took a dimension of the new image, or the new, and we divided it by the dimension of the original. When it comes to dealing with scale factor, when it comes to dilations, what we're going to be looking at is a dimension of the image divided by a dimension of the pre-image. Or if we have ordered pairs, we have x and y, we have x prime and y prime. Remember, this is the pre-image here, this is the image. So we would look at x prime divided by x, or y prime divided by y. Any and all of those are going to be very much appropriate. It just simply depends on what is given to us. So in example 3, the example says the pupil of Josh's eye is 6 millimeters in diameter. His doctor dilated his eye by using medicine, and it is now 9 millimeters. So what's the scale factor? And then isn't it an enlargement or a reduction? So first thing we want to look at is the dimensions. So here's one, and here's one. This is the new dimension, so we're going to go 9 millimeters. This is the original, which happens to be 6 millimeters. So if I simplify this, my scale factor is either going to be 1.5 or 1.5. Notice, there are no units. That's very important when it comes to scale factors. Scale factors don't have units. If it had a unit, it would actually be called a scale. But in this case, there are no units. So because my scale factor is 1.5 or 1.5, this is greater than 1, which means this is an enlargement because k is greater than 1. All right, that is the end of this lesson. If you have any questions, please let me know.